All right, I think we're ready. Jenny, are you? Yeah.
Yes, sure.
Okay, so hello everyone. Welcome to our WIG webinar series. As you can see, I'm not the regular host. I'm a substitute host because the regular host is presenting. So before we move on to the presentation, just a couple of housekeeping stuff. So this is the 5th in the series, so the webinar. And just know that this meeting, the webinar is being recorded. So the recording will be available on our YouTube channel in a week or so. So if you want to follow us, like I will be sharing the YouTube and LinkedIn link in the chat later. That way you can follow us on both channels. And also, please note, please mute yourself for the duration of the presentation. And during the presentation, if you have any questions, just put them on the chat, actually, not on the Q&A, just on the chat. So we'll be taking the question later on. Moving on to the presenter for today, as you know, Jenny, our regular host, Jenny will be presenting today, and she will be talking about the data queue for Ireland. So she will start with her introduction and the presentation. So Jenny, the floor is yours.
Great. Thanks very much, Sita. Our roles have been reversed from the last time when I was hosting and you were presenting.
Exactly.
Yeah, it's nice to be presenting for a change, having hosted a few of these webinars now. And happy May Day, everybody. My name is Jenny Hanafin. I'll just speak a little bit about myself before I go on to the work. I guess I started off in Galway. I did a bachelor's in marine science. In fact, we were the very first year to graduate in a marine science degree. Back then, the Martin Ryan Institute had only just been built. And I went on to do a PhD in Miami in physical oceanography and meteorology. I worked in various postdocs. I worked in Imperial College doing operations science for a satellite sensor there, an atmospheric satellite sensor. I did some work with Met Éireann and UCD on the first climate modelling for Ireland, the regional climate modelling. I did another project with Met Éireann and then NUI Galway, now University of Galway, having gone through another name change recently. Then I went to France and worked in France for a while with Ifremer, which is the French Marine Institute on wave modelling. Came back to Ireland and I worked with TechWorks Marine for a couple of years. We started off their Earth observation activity there and modelling activity. And now I'm working for iCheck. So I'll talk a little bit about iCheck in the presentation. But I'm the Earth Observation Activity Lead at iCheck. So I kind of have grown that group and we are involved in a few different projects. We're looking at we're monitoring the restoration that's being done on peat bogs across Ireland. So Bord-na-Móna is blocking up the drains in their peat bogs, and we're using satellite data and models to see, how those habitats are being restored. We're also looking at electric vehicle chargers. So the local authorities are in charge of the rollout of public chargers in the county, and they have no numbers. Basically, they've no data to base their estimates on. So we've been using satellite data to look at everybody's driveways and to see to estimate the number of houses that have driveways and don't have driveways in an area, because that will tell the local authorities which areas will have greater demand for public chargers if you can't actually pull your car in and plug into your home charger. We've also been involved in looking at AI for Earth observation and developing specifications around that for the European Space Agency. And we are currently involved in a number of sort of data space activities, which I'll talk a little bit about in my iCheck introduction. But let me get going with my presentation. So the main project I'm going to talk about today is the EODC4I, the Earth Observation Data Cube for Ireland. And I'm working on this with a few colleagues at iCheck that are involved in platform engineering, data science, and Earth observation. And we also have partners, Fiona Cockwell in UCC and Guy Serban in EO Analytics are helping us out with parts of the work. So I'm just going to introduce iCheck because iCheck is one of Ireland's best kept secrets. It's a very small research centre. We have, I think it's about 45 people at the moment. We're split between Galway and Dublin, and we run the National High Performance Compute Service for Ireland. iCheck do amazing work, but nobody ever hears about it because the only people who know about iCheck are the people who use the services, which is a very small handful of people. We are currently funded by DeFerris, but we also bring in our own funding from different projects. And if I just move on, so the vision is to deliver computer modelling and data intelligence for Ireland. So our business model has changed in the last few years to include data as well as compute services. And we're really starting to ramp that up, and I'll talk about that in a little while. So most of the Earth observation comes under our strategic objective 4 to deliver HPC for good. We also do some strategic objective 2, advanced digital skills, because we are developing Earth observation courses. And then our other strategic objectives are to enable excellence in science. That's by supporting people to use the National High Performance Compute system, but also to use other supercomputers across Europe. And then accelerating economic development through collaboration with SMEs and public sector. So Caspar is our last supercomputer system was called K, and Caspar is the upgrade. It has been funded by EuroHPC to a quite a large level. So EuroHPC, in their HPC strategy for Europe, decided they were going to fund one very large supercomputer, which is based in Finland, I think. There are 5 kind of medium range, and then all of the other computers would be lesser range. But Ireland was picked as being one of the 5 medium range. Now, medium range still means that we're going to be in the top 100 supercomputers in the world. And this is the kind of schematic, excuse the interruption there, the joys of working at home. This is a schematic, so it'll be centered around a data lake. There'll be HPC for big data analytics, accelerated HPC for AI, traditional HPC, a quantum learning platform, and then a private cloud for federated services. And so talking about data spaces, we'll be transitioning from the system on the left, where we provide infrastructure and different projects are kind of built higgledy-piggledy on top of that infrastructure for different user groups. And we are going to centralize all of that. So we'll end up with our data in the center and the different compute modules around the data. Now, the funding has been confirmed from the European side. The national funding is still, we're working on it. DeFerris are currently reviewing iCheck in order, it's a large amount of money, so they have to go through due process. So they're reviewing our services at the moment, and hopefully we'll get the confirmation towards the end of the year. So currently we do provide data services at the European level. We're a back end for the Copernicus Climate Change Service. We have data management and HPC processing, and we also have the Global Observations Database. We also provide the back end to the ESA Validation Data Center. So we provide a global archive of the atmospheric satellite data, and that's available for CalVal scientists to access, to compare their in situ data with. A very persistent cat, excuse me. And we're really ramping up our data activities. We have had for a number of years the ESA collaborative ground segment. So we have a direct data downlink from ESA. We're a member, we're on the Open Geospatial Consortium. We're on the ESA Data Coordination Board. We're on the CIOS Working Group for Information Systems and Services. Our data store is part of the Copernicus data space, and you may be aware, so they have changed their data services from being from the Copernicus hub, the Sentinel hub, into this Copernicus data space where the data is distributed, but you access it from a portal, but you could be downloading data from Greece or Ireland or Finland or wherever it's being stored. And we're a member of the European Open Science Cloud Future User Group. So looking into the future at how European scientists are going to be using data and data spaces. So the Earth observation, why am I talking about all that? The Earth observation data cube, the long-term goal for that is that it would be included within those European data spaces. So we're working hard to make this system interoperable with those systems. We're also working on different projects looking at the technology of data federation so that, again, a user in Italy can look at data from the Irish data cube, look at it from the Austrian data cube and the Finnish data cube, and apply their AI model or do their analysis on the data. But this is part of the European drive to make scientific data open access and to increase the sharing and thus increase the value of the data that's being produced. This specific project is to encourage widespread use and uptake of satellite data in environmental research and monitoring applications. So we're going to make the data easier to use, to provide EO data for federation with other data spaces, to give access to an extensive database of the open satellite data with an archive going back 40 years from Landsat for long-term change analysis. And we'll also be providing processing capabilities next to the data cube. So the project activities, we started off with a user consultation where we contacted different Earth observation data users in academia, in industry, in the public sector, to ask them what they thought they needed and what they thought should be provided. We went through a review of the available technologies, and we are currently at the implementation stage. So we have our spatial database, we have our data management chains are in preparation at the moment, and we're ready to populate the data cube with analysis ready data from Sentinel. So our aim is to provide pretty much all of the open data that's available, Landsat, Sentinel-1, Sentinel-2. We'll put that together with our own high resolution climate reanalysis and climate model data that's generated at iCheck. And we'll put in additional data in as far as we can. So a high resolution DEM, we'd love to be able to put in the EPA land use map, but apparently there are access restrictions on that. So we'll have to figure that bit out. And then there will be 2 use cases that'll be carried out on the data cube. So the data services that we're going to provide, daily updated Landsat Sentinel-1, Sentinel-2 analysis ready data. So that means we've done the atmospheric correction, we've reprojected it to the Irish, the ITM, and it's basically ready, you know, cuts out all of the pre-processing steps. An archive of Sentinel-1, Sentinel-2 and Landsat as far back as we are able to gather. Harmonized Landsat and Sentinel optical data. The high resolution climate model data archive, the Copernicus DEM, and it'll be covering Ireland and the coastal areas. The data access services we're planning is an image or dataset browser. So our main technologies for cataloging will be based around STAC, the spatiotemporal asset catalog, which is what's being adopted by all of the space agencies and data spaces for these data, and other data spaces are looking at that standard to use it in their spaces as well. You'll be able to access the data using Jupyter notebooks, and then there'll be Dockerized workflows for SnapGPT or that type of activity. And then we'll have the OGC, WMS, WCS, WPS services for GIS applications. At the moment, iCheck offers processing resources. So if you apply to iCheck, if you have a project that needs supercomputing resources, you apply to us. And you're basically given them depending on the size of the project, and that would be the same for DataCube users. Once the DataCube is up and running, we've chosen 2 projects to kind of show the value of presenting data in this way, and they're really all about, big data. So in the first one, something will be a data set will be generated, which is something the OPW mentioned to us a couple of years ago. So the SAR provides a time series of surface water every 3 or 4 days. So to look back over that archive and determine whether pixels are wet and dry, and then also determine whether that's a flood, whether it's seasonal like Turlock's, or whether it's a permanent water status, and then produce maps across a nationwide map of historic flooding and statistics for each pixel. And then UCC will be looking at land cover trends. So NDVI trends from 1990 to 2025, associating pixels with land cover, the National Land Cover Map, looking at which pixels have constant land cover and which have changes, and then producing a map of land cover changes between 1990 and 2025, and evaluating what has caused those changes, whether it's deforestation, whether it's agriculture, wildfire, or a gradual change of habitat. This slide is really just to say we are using the exploitation platform common architecture, which was developed by an ESA working group. And the main aim of this and the main reason for us using it is for interoperability and eventual federation. So in terms of interoperability, so we're looking at things like identity and access management. So you could have a single sign-on with ESA, for example, or with the Copernicus data space. So you don't have to have a different user account for each of those spaces. Looking at the processor development environment, the resource catalog. So all of the interoperability of all of those things have to be taken into account when you're designing a system like this that will be interoperable with other similar systems throughout Europe. And I suppose this is the kind of basic idea behind the EPCA. So your host infrastructure down at the bottom, you have data resources and compute resources. Above that, there's an access gateway. Then you have the kind of processing applications, data services, and catalogs. And then at the top, you have the users. So kind of basic consumers of data, just accessing through a web portal, or experts accessing through a command line or a development environment or other external application. Oh, and I guess that's it.
All right, thank you, Jenny. Let's see if
Jenny
have any questions. Sorry, yeah. Thank you, Jenny, for the nice talk about the Earth observation DDQ. If there are any question, can you guys put on the chat box there, not on the QA, but chat box, where people are putting or will put the question. I have one question, Jenny. Like, I know for accessing the computing resource, and I check you, like, it's not free, like there is a computing cost. So what about for the data cube? Is it going to be free, or there is like people have to pay for it?
Yeah, so I mean, it's not free, that there is a cost to those resources. But those resources are paid for essentially by the government for scientific users of the supercomputer. And it will be the same for the data cube and the processing resources that are offered to use the cube. There are a number of schemes for, like, SMEs, for example, to use the supercomputer, and it will be the same for the data resources.
All right.
So we could use Enterprise Ireland vouchers or that type of thing to pay for something if an SME needs access.
All right, thanks for that. I also have another question, actually. It just looks so. Recently we had been looking for like coherence data, and we realized in the market that's the missing part, because coherence is so difficult to compute. It's computing, like, like it's very expensive in terms of computation, and also that's not something GEE provides. So there, it looks like there is a gap there, like most of the people would be interested in coherence, but no one is providing. So is DataCube gonna resolve that, or like, is coherence one of the ARD product, unless it's ready product there in the list?
Yeah, so the SAR ARD products are less well mature. They're not as mature, let's say, as the optical products, because I suppose they don't have as many users. And we are not planning to produce coherence. We're planning to produce normalized radar backscatter. But I would suggest that it could be less expensive to do it to compute it using a data cube. There is another market gap, I think, at the moment, and that is in adapting SAR processing for HPC use. So they're really, and it's actually an activity we're carrying out for the European Space Agency at the moment, is looking at HPC and what role can it play in their data services. But there's definitely a lot of optimization and parallelization that can happen when you're processing satellite data. So that's definitely another gap in the market, and be a growth area over the next few years. So that might be the answer, possibly.
Yeah, because during that research, trying to find out, coherence data, there were few European country, they had the coherent data just for the one country, so it looks like it's just no one can afford to do it for the whole world. So probably, individual countries, like, can only take it.
Yeah, so it's not included in our current project, but again, this is just one part of a much larger activity.
Yeah.
So it's something that we could build on, and we also want to connect up the EO data cube with other data spaces. So, for example, we're working on a proposal to develop an agriculture and environmental data space. So linking up different data sets from DAFM, PA, Quilcha, the MPWS, to make them easier to use and to bring them together. I forgot where I was going with that, but yeah.
So yeah, maybe I don't see any questions, but I'm sure everyone might be wondering, when would this be ready? What's the timeline or evolving timeline, Jenny?
No, that's the question I don't want to answer, actually. Because of the delays with funding for Casper, it has also delayed this project. Now, we are currently trying to get a plan in place to, we're going to have to pause the project for a few months, actually. And we're trying to get a plan in place to continue it in early 2025. So originally, the The data cube itself would have been ready this September and then open to the public September of next year. That'll be delayed now by at least 6 months. So I would say the end of next year. Ask again, and we'll have a better answer.
Definitely. It's one of those interesting projects, it's like first time in Ireland, so I'm sure everyone would be like, okay, just want to check it out. How is it, Yeah.
Yeah, sure. Yeah.
So any other things you want to cover, Jenny, how they can follow you, or any like resources on finding out, following up this, is there a channel? I think probably there is a Twitter feed for this project, I guess.
Well, we actually haven't started one because we knew these delays were coming down the line. So I think once we're more clear on where we stand later in the year, there'll be more information coming out.
Yeah, so I should say X, not Twitter. Sorry.
Yeah. No, we'll definitely have X, and also the iCheck LinkedIn account.
Yeah,
is a good place. I'll just put up a link to that.
Perfect. Yeah, that sounds all good, Jenny. Thank you so much. Thank you so much, Jenny, and all the audience there. Also, one last announcement there. We will be taking summer break, so we'll not be in for July and August, but we'll be back with our 5th of June. So sorry. Oh yeah, and so our next one will be on 5th of June. After that, we'll be off for 2 months, and we'll be back in September. Yeah, so that, and please follow us on LinkedIn and YouTube. In that case, I think, thank you everyone for joining, and thank you, Jenny.
Thanks a lot, Sita. Thanks for hosting today. Thanks, everybody.
Thanks.
Bye now.